Morning. Assalamualaikum. Okay, before I start, I want to confirm on the changes. Friday class will change to Tuesday. Is it okay? Friday class change to Tuesday, 2 to 3:30 p.m. Okay, great. So Friday no more class. Asha, can you see the screen? Sit there. Yeah. Okay. Okay. Okay, so we proceed with the new topic. Sorry, new subtopic in chapter 4, which is the interpolation. Here is Lagrange interpolation. Okay, Lagrange interpolation. Last time we had done on Newton interpolation. Okay, now it's Lagrange. The difference is on the formula to calculate the weighting function. Okay, last time in Newton we have this Fnx equals to BO. You have the B's. Okay, you need to calculate the B's. Okay, you need to calculate the B's in Newton. Okay, but in Lagrange, slightly different method where you will need to find the weighting function. Okay, actually the Lagrange is reformulation of Newton polynomials. Okay, so this is, let me make it bigger. This is the equation, the formula for Lagrange interpolation. F and X. N is the order. Wait, I cannot write. Okay, N is the order. Yes, N equals to the order. So Fn1, N equals to 1 is linear. 2 is what? Quadratic. Cubic. N equals to what? Cubic. If cubic, 3. Okay, N equals to 3. Okay, so this is Lagrange formula, where it is the products of L is the weighting function. Okay, Lix is the weighting function multiplied by the Fx. Okay, Fxi. Where this Li, okay, Lix is calculated using this formula. Okay. Okay, as you can see over here, okay, I want to highlight this on the weighting function formula. Lix. I is referring to the I always start with 0. L0. Okay. Now for example, if you have f n equals to 2x. Okay, so this equation will be expand L(x) multiplied by fx naught. Okay, plus L1 x multiplied by fx1. Okay, plus L2 x fx2. Okay, for example, you have n equals to 2. Now notice that I is this one, L0 L0 fx0. It starts from 0. The starting point. Okay, the first point. L1 fx1. L2 fx2. Okay. Now to find the Li, each Li will have different values. Okay, for example, we have L naught, L0. So L naught equals to N here, N equals to the order just now. Let's say we have order 2. Okay, now here, notice here, J equals to 0, meaning that J starting from 0. Okay, here starts from 0. Start from 0. J start from 0. And here J cannot be the same as I. Okay, J cannot be the same as I. Because if let's say L naught, so X, okay, this is the summation, products of N equals to 2. J must start from 0, but J cannot be 0. Okay, here I equals to 0. Okay, now this refers to the I. Then X minus Xj. So Xj here, J start from 0, right? X naught over Xi, which is X naught. And then J cannot be the same as 0. Okay, because if J equals to 0, the value here will be 0. So you cannot divide 0, right? So that's why here cannot be 0. Okay, here will become X1. Okay. Now here we have N equals to 2. So you will have another one. X minus X1. Okay, so here X naught minus X2. Wait, let me confirm on the values. Okay, sorry. You see, okay, I made a mistake over here. See. Remember that J cannot be 0, correct? So up here also is Xj. So Xj here cannot be 0 as well. Okay, X minus X1. Here X minus X2. X naught minus X2. Okay, so from there, you sub your value of X, what you need to find, and the value of X1, X2. Any question up to here? This is how you should expand the equation. Okay, so I explain first how to expand and the formula. Later we'll do exercise. Okay, so this one, similar as just now. F, let's say here is N equals to 1. Okay, so this one is the L naught. This is L1. Okay. Now, sometimes you can memorize this formula straight away, but again, it depends to the n. If n1, this is your L0, L1. But if n equals to 2, your L0 will be different. So I would suggest you to understand how to use this formula, the weighting function formula. Okay. Okay, this one, the equation for else when n equals to 2. Okay, you see, this one is L0, similar to what I explained earlier. It involves x1, x2. Okay, this one is for L1, this is for L2. If n equals to 3, then L0 will be different. Okay. Now this is when n equals to 3. Notice the difference on the else formula. L0, L1, L2, L3. Okay, how they expand. All of this using the weighting function formula. Okay. Now let's try. Wait. Before we try. So this is the same as I explained earlier to find L0, L1x. Okay, let's say your n equals to 1. First thing, expand the equation first. Okay, expand the equation. Where it will involve L0 and L1. Okay, remember n equals to 1. It depends to your n. Okay, so from there, find your L0 where the products of L0x. So J must start from 0. So x minus x0. So this one is x1. Should not be x0. X1. Okay, and but J cannot be 0. Okay, so that's why you have x1, x1 over here. Then find your L1x. J must start from 0. Okay, must start from 0, but J cannot be 1. So that's why it only involves x0. Start from 0, but cannot be 1. Okay, let's say you have n equals to 2. We continue the one that we did just now. Okay, let's say n equals to 2. The main function of Lagrange is this. This is the main equation. Next, n equals to 2. Okay, we expand the equation where L0 x, fx not, okay, plus L1 x, fx1 plus L2 x, fx2. Okay, second step is to find the else value. Okay, L0, we start with L0. Remember, J start from 0 but cannot be 0. Okay, x minus x1. xi, I refers to the knot, x naught minus x1. Okay, this one later you will sub your numbers. Sorry, not finished yet. Remember our order equals to 2. So involve up to x2. Okay, multiply by x minus x2, x naught minus x2. Okay, x naught remain because it refers to xi. Okay, xi is the I over here, referring to the L naught. Same, huh? Now, L1. Sorry. L1, remember J must start from 0, x0, but J cannot be the same as 1. Okay, so x minus x0, x minus x2. Here, x1. So you'll find your values. Okay, similar to L2. I do it up here. So x minus x naught, x2 minus x naught, x minus x1, x2 minus x1. Okay, that's how you find the L values. Once you obtain the values, then only subs into the main equation. Step 3, sub the L's into the main equation. Sorry, not main equation, the expand equation over here. Okay, plug in into this. Then you will find what is your F2x. Okay, up to there. 2 minutes for you to digest. Okay, we try this example. I extracted from textbook Lagrange interpolating polynomial. Now, given it asks you to use a Lagrange interpolating polynomial for the first and second order. So first means n equals to 1. Second order means n equals to 2. Okay, so here you will have two set of answers, f1x and f2x. To evaluate ln 2. So your x here is 2. Here it gives you the data points, x0, x1, x2. So your x equals to 2. So your x is in between this. Okay, for the first one, n equals to 1. Your data points will be the first two, x0, x1. Remember, n equals to 1, how many data points that you should have? 2, okay? So x0, x1. Why not x6? Sorry, x0, x2. Can you take x0 and x2? Can actually, because your x is still in between these numbers. But then the difference will be, the error will be quite big. Compare, you take 1 and 4. Okay? Okay, so let's say we choose x0 and x1. Expand the equation. Step 1, expand the equation. The equation here means from the Lagrange equation. So f1x, you will have L0, starting from L0. Multiply fx0 plus L1x multiply fx1. Okay, up to that. Step 2, find the weighting function. The here weighting function involved is L0 and L1. Okay, L0. Remember the equation Li. L0 equals to products of x minus xj, xi minus xj. N equals to 1 over here. Okay, so j should start from 0. But j cannot be the same as 0. Cannot be 0. J cannot be 0. Okay. Okay, so we expand the equation. X here equals to what? Where's your x? 2. Okay, Tasmia? X equals to 2. So 2 minus, sorry, before that. We put up the equation first, step by step. So here it involves x minus x0, but remember j cannot be 0. So here x1. x0 minus x1. Okay. Then only you sub in the values. X equals to 2. So your x1 is what? 4 over x naught 1 minus x1, which is 4. Okay, what you get? Correct. 0.6667. Let me know if I go too fast. You just stop me. Okay, Ruben? Then L1, remember J must start from 0, but J cannot be 1. Okay, so it involves x minus x naught, x naught, xi, not x naught. So it will be x1 over here, minus x naught. Multiply x minus, that's all lah. Because n equals to 1, right? You cannot write as x1 because j cannot be 1. Okay, so this part is wrong. Not required. So what you get for your L1? 0.3333. Okay, once you obtain the L values, plug into the expanded equation. Okay, so your F1x, L naught, which is 0.667, multiplied by Fx naught. Fx naught is 0. Plus L1, the one that you calculated, multiplied by Fx1, okay, which is given over here. Okay, what you get? 0.4620. 21. This is what I get, 205. 0.46205. So F12 equals to 0.46205. How to know your answer is correct? Check in between these numbers. your answer should fall in between these numbers. Okay, so your final answer is in between these numbers. It should be correct. Okay, then try when n equals to 2. N equals to 2, you need 3 points. Okay, 3 points. So step 1, expand the equation first. Because you should know which L, until which L involved. So here expand L0, L1, L2. So it involves 3L, 3 weighting function. Okay, then from there, calculate your L0, L1, and L2. So L0, remember n equals to 2. Now here, x minus xj, xi minus xj. J should start from 0. Okay, so your x just now is 2. 2 minus xj. J cannot be 0, so it should be 1. Plug in the equation first. Okay, x1, x0 minus x1. Multiply by x minus x2, x0 minus x2. Then subs in your value. X equals to 2, x1 is 4. Okay, x0, 1, 4. X2 is 6. Okay, so you should get negative 0.2. Right? Okay, try to calculate for L1 and L2. Sorry, L0 is not negative 0.2. That is L2. Sorry. My bad. L0, you should get 0.533. Okay, once you get sub into the equation, the expanded equation, then you'll get your F2x is this figure, 0.56589. Okay, so I can see all of you understand and know how to do it. So let's try this example. This one also from textbook. Given the data set, you have T and Z. Okay, it asks you to calculate Z at T 2.5 by using Newton and third order Lagrange. Okay, we focus on Lagrange only, the B. For the Newton, you can calculate later on your own time. Okay, we focus on B. Use a third order Lagrange interpolating polynomial to determine the Z. This one is Z. At T equals to 2.5. So N equals to 3. T is 2.5. So your T is in between here. Okay, it asks you to calculate the Z over here. Okay, so this is the data set given. So you must identify what is your data. What is your data point? Okay, if given like this, first step, you should identify your data. N equals to 3, so it involves x0, x1, x2, x3. 4 data points. Okay, so x0, which one should be your x0? 2.1. Okay, let's say you choose 2.1 to be your x0. You can also choose 2.2 to be your x0. Okay, so let's say 2.1 is your x0. So x1, 2.2, x2, 2.7, x3 is 3. So copy back the fx for the related x's. Okay, this first step is important for you to list down. If you are given the set, this data set, okay, it is important for you to identify what are the points. Because if of this value will brings you half mark. Okay, usually it will brings you half mark. Now, after you identify the data, expand the equation. It involves n equals to 3. So F3, 2.5. Your x, which is your t, goes to 2.5. Lagrange, okay, Lagrange, so it involves the weighting function. Okay, expand the equation first. Okay, then calculate your L. Okay, then arrange what is your L naught, L1, L2 up to L3. Okay, L naught here is 3 up to N3. So x minus x1. Okay, repeat the same step to find what is your L2 and L3. Okay, so L0, L1, you should be getting that figures. Proceed for L3, sorry, L2 and L3. Then subs into the main equation. Final answer is 17.15. Here. Surround that figure. It's to the axis that you choose. The final answer using this set of data points should be around 23. 23 point something something. Okay, it's up to the decimal point that you choose. The answer given over here, the 17, perhaps this one I use different data points. Okay, but as long as your answer is in between 10 and 36. Okay, your answer should be between these two figures. Newton and Lagrange is in CLO 3, interpolation. Okay, one question will be asked in the final exam on the interpolation. So this topic alone will bring you 20 marks. Newton, 10 marks. Lagrange, 10 marks. Okay, just let me share with you how I distribute the marks. For example, for this question, it asks you to find using Lagrange. Each data points will bring half marks. Okay, so that's why it's important for you to list down your data points. So here, for the first step, already contribute 4 marks already. These two, here 2 marks. The L value contribute 1 marks. Okay, L1, L not L1, then L2, 1 mark, L3, 1 mark. Okay, how many already? 2, 4, 5, 6, 7, 8. Step 2 over here. List down the expanded equation, also bring 1 marks. Okay, then final answer 1 mark. That's how you get 10 marks. Okay, if let's say you don't have enough time to do, just list out your data, write out your equation, still get marks. Okay. Final answer for this is 23 again. 23 point something something. Okay, this 17, perhaps I use different data points from my calculation earlier. Okay, as long as your final answer in between 10 and 36 should be correct. This kind of data points, you can have a few of data points. You can, this one, you start from here, x naught. You can also start from 2.2 as x naught. Okay, or you can also start from 2 as x naught. So that's why if your answer is different from mine, I will check what is your data points. Okay. Okay, any questions? You should try later on in your own time for the Newton method. Using the same data points that you chose earlier, try to calculate what is the final answer. You should be getting the same answer. Okay, remember Newton, you need to find the B, the B's value. Try n equals to 3 as well. So for Newton, you will have B naught, B1, B2, and B3. Okay, so we are done with Newton and Lagrange. Any questions? Huh? Ruben, clear? Next, tomorrow we have class 2 p.m. at C407. I will start differentiation, chapter 5. Okay? Okay, that's all for today. Thank you.